Welcome back to DSR. You can't die in quantum mechanics. That's not a metaphor. It's a literal prediction of the most bizarre theory in physics, quantum immortality. Imagine this: every time you're about to die, the universe splits into infinite parallel realities. In one, you're alive. In another, you're dead. But here's the twist: your consciousness only perceives the reality where you survive. It's like a cosmic game of Russian roulette, but with infinite bullets and infinite lives. This is the mind-bending core of quantum theory, a realm where particles don't just behave like particles, they behave like something else entirely. Let's rewind. Most of us grew up believing the universe is predictable. A ball rolls down a hill, it follows a path. A car crashes, it obeys physics. But quantum mechanics says, no. The world isn't made of solid, predictable objects. It's made of probabilities. Every particle exists in a state of superposition. Not here, not there. Both. All at once. Until you look. Picture two narrow slits cut into a screen. Shine a beam of particles, electrons, photons, even molecules, through them. What do you see? If you expect particles, you'd expect two bright lines on the other side, like bullets passing through two doors. But what you actually see is stripes. Dark and light bands, like ripples in a pond. This is interference. A wave pattern. But wait, these are particles. How can they act like waves? Here's the kicker: even if you fire one particle at a time, the same pattern emerges. Each electron, as if guided by a ghostly hand, passes through both slits simultaneously and creates a wave-like interference. It's as if the particle is everywhere at once. But then, here's the twist. If you place a detector near one slit to see which path the particle takes, the pattern vanishes. The stripes disappear. The electron behaves like a particle. It's as if observation itself forces the particle into a single state. This isn't just a trick of the light. It's a fundamental truth. Particles are waves. Waves are particles. They're both. They're neither. They're quantum. And this duality isn't limited to electrons. Physicists have done the same experiment with protons, neutrons, atoms, even molecules. In 2019, scientists at the University of Vienna observed interference patterns with molecules containing 2,000 atoms. These aren't tiny specks of dust. They're complex, massive objects. Yet, under the right conditions, they behave like waves. But what if we could isolate ourselves from all external influences? What if we could stop observing? Then, we'd be in a state of superposition. We'd exist in multiple states at once. We'd be everywhere and nowhere. This is the ultimate paradox. Reality isn't fixed. It's a tapestry of possibilities, woven by observation. But here lies the paradox: if all possibilities exist simultaneously, then you, or the viewer, the thinker, the experiencer, are not a single entity, but a multitude. You are the observer in one universe, the skeptic in another, the believer in yet another. The act of your watching this documentary is not a passive event, it is a quantum act, splitting the cosmos into infinite branches with every moment. You are not just witnessing the universe, you are participating in its creation. This is why the many worlds interpretation has become both a beacon and a storm. It offers no need for a collapse of probability, no mystical hand guiding the universe's hand. Yet it demands an unsettling truth: every choice, every thought, every breath you take is a fork in the road, birthing a universe where you made a different decision, a different thought, a different breath. You are not alone in this dance of existence, you are everybody. And yet, for all its grandeur, the theory remains a shadow of a shadow. No experiment has yet confirmed the existence of these parallel worlds, and some physicists argue that it is a philosophical convenience, not a scientific necessity. The question lingers, is the universe a single, boundless ocean of possibilities, or a mosaic of isolated realities, each one a universe unto itself? The answer, if it exists, lies not in the equations, but in the silence between them, where the quantum realm whispers its secrets to those who dare to listen. And in that silence, the universe waits. And in that silence, the universe waits. It waits for us to grasp the impossible, to confront the terrifying beauty of a reality that defies our senses. Imagine, if you will, a universe where every choice, every flicker of uncertainty, fractures existence into infinite threads. Each thread a world, each world a version of you, some alive, some dead, some dancing through galaxies, others trapped in the void of oblivion. This is the many worlds interpretation, a theory that dares to say, every possibility is real. But here's the paradox, you, the observer, are trapped in a single thread. Your consciousness, that fragile, flickering thing, can only perceive the branch where you remain. The others, those where you die, where you fall into black holes, where you dissolve into entropy, exist, but they are silent. They are unreachable. Your mind, your sense of self, is bound to the world where you survive. Even if the odds are stacked against you, even if the universe conspires to erase you, your awareness will always find a path. A path where you are. This is not just physics, it is philosophy. It is the question of why we exist, why we feel we exist. Max Tegmark, the mathematician who dared to imagine a universe built from equations, proposed a radical idea, that all possible mathematical structures are real. That our reality is just one of an infinite number of equations, each birthing a universe. In his book Our Mathematical Universe, he describes a thought experiment that would test this theory. Picture a device, a quantum Russian roulette, firing bullets with 50% probability. You place your head under it, and wait. If the many worlds interpretation is true, after each click, the universe splits. One branch, you live. Another, you die. But your consciousness, that elusive, subjective thing, can only cling to the living branch. You hear only clicks. You feel only survival. But here's the catch, the other branches don't know you're dead. To them, you're gone. To them, you're a ghost. And yet, in your mind, you are alive. You are the only version of yourself that remembers. You are the only version that wakes up. This is the horror of the many worlds. It suggests that every death, every failure, every moment of despair is not an end, but a branching. You are not alone in the multiverse. You are everywhere. You are the man who survived the crash, the woman who escaped the asteroid, the child who outwitted the void. And yet, you are also the one who died, the one who burned out, the one who never existed. But what if the universe is not just a multiverse of possibilities, but a mathematical multiverse? What if every equation, every theorem, is a world? What if we are not observers, but participants in a cosmic game of infinite variables? Tegmark's theory posits that reality is not a single story, but a library of equations, each one a universe, each one a truth. In this view, your consciousness is not a spark of life, but a computation within a vast, unending code. You are not special. You are necessary. And yet, the question lingers, if every possibility is real, does that make anything real? If you die in one branch, does that mean you never existed? Or does it mean you always existed, just in a different version of reality? The many worlds interpretation does not answer these questions. It invites them. It forces us to confront the terrifying truth that we are not the authors of our fate, but the characters in a story written by the universe itself. So, when you next face a choice, remember this: the universe is already splitting. You are already everywhere. And in that endless, branching sea of possibility, your consciousness will always find a way to survive. Because that is the nature of the multiverse. It does not end. It multiplies. And you, dear listener, are both the creator and the creation of it. The universe does multiply. You, dear listener, are both the creator and the creation of it. Imagine, if you will, a single photon, a particle of light, traveling through an experiment. It passes through two slits, and instead of creating two distinct paths, it interferes with itself. The result? A pattern of bright and dark bands, as if the photon had somehow split into a wave, spread across both slits, and then recombined. This is not a trick of light, it is the very essence of reality. The photon is both a particle and a wave, a paradox that defies classical logic. It exists in a state of superposition, a condition where it is simultaneously everywhere and nowhere until observed. But here's the mind-bending part: when you look at the photon, the wave collapses into a single point. The act of observation forces it into a definite state. This is the observer effect, a cornerstone of quantum mechanics. Yet, the question lingers: what does it mean to observe? Is the universe inherently probabilistic, or is there a deeper, hidden order we've yet to grasp? The double-slit experiment is not just a curiosity, it is a mirror held to the fabric of existence. It suggests that reality is not fixed, but potential. The universe is a vast, unspoken equation, and we are its variables. Now, let's return to the story. That morning, as I teetered on the edge of death, my body, a collection of atoms, was no different from the photon. Each atom in my cells, every electron and proton, was in a state of superposition. My consciousness, that intangible thread of awareness, was woven from the same quantum threads. If the universe could exist in multiple states, could I too? The many worlds interpretation, proposed by Hugh Everett, posits that every quantum possibility branches into its own parallel universe. In one, I survive, in another, I die. But which one is real? This is where the paradox deepens. If every possible outcome exists, then you are not just one person, you are infinite versions of yourself, each living out a different path. The idea of quantum immortality emerges. In every universe where you could die, there exists another where you don't. You are, in a sense, eternal. But this is not a comfort, it is a horror. To exist in an infinite multiverse is to be everywhere and nowhere, a ghost in the machine of existence. Yet, not all physicists agree. The Copenhagen interpretation, championed by Niels Bohr, argues that the act of observation collapses the wave function, rendering the universe deterministic. In this view, the universe is not a collection of possibilities but a single, coherent reality. The double-slit experiment is not a proof of parallel worlds, but a demonstration of the limits of human perception. The universe, in its true form, is incomprehensible. But here's the catch: we are the observers. Our minds, our consciousness, are the instruments through which the universe reveals itself. If the universe is a quantum soup of possibilities, then we are both the architects and the audience. The question is not whether we can understand it, but whether we should. And so, we return to the story. That morning, as I stared into the abyss of the double-slit experiment, I realized something profound. The universe is not a clockwork machine, but a living, breathing enigma. It is not bound by the rules of classical physics, but by the strange, beautiful logic of quantum mechanics. And in that logic, we find our own reflection, a mirror of infinite potential, where every choice, every moment, is a thread in the tapestry of existence. But what does it mean to live in such a universe? To exist in a state of superposition, where every possibility is real until observed. To be both alive and dead, until the act of being collapses the wave? The answer, perhaps, lies not in the equations, but in the question itself. For in the end, the universe is not a puzzle to solve, but a story to live. And you, dear listener, are the author. Quarks, spinning inside the proton-like galaxies in space. These quarks are not mere points, but complex entities bound together by invisible threads of the strong nuclear force, the force that holds them in place. It is a force as mysterious as the universe itself, a universe that once emerged from chaos and now gives rise to stars, life, and thought. But if quarks are made of something, then where is the boundary between a particle and space itself? This is where the true paradox begins. Quantum mechanics does not merely describe the world, it rewrites the rules of the game. Superposition, wave-particle duality, entanglement, these concepts are not abstractions, but aspects of reality that we struggle to comprehend. Even in laboratories, where scientists smash particles together at energies approaching those present at the birth of the universe, they are confronted by a question that remains unanswered: what is matter, really? Imagine standing before a screen displaying the image of an atom. You see an electron that is here one instant and there the next, as if it has leapt across space without traveling the distance between. This is not an optical illusion. This is reality. And if an electron can exist in two places at once, then what about the proton, the neutron, the quark? What if they too are not particles at all, but waves? And in the midst of this chaos emerges an idea that forces us to think differently. Perhaps the universe is not merely built from particles. Perhaps it is itself a construction. Quantum mechanics does not tell us how everything works. It tells us that we do not know how everything works. And that is not a flaw. It is an opportunity. Because if we cannot understand what matter is, perhaps we cannot understand what reality is. And so the question returns to Tegmark, to the professor, to the thing he failed to grasp 20 minutes ago. Perhaps he was not foolish. Perhaps he simply saw too little. And now, as we stand on the threshold of a new era, where atoms break apart and particles dance in the vacuum, we begin to understand the universe is not a construction set. It is a game. And we are its players. Werner Heisenberg developed this idea further with his famous uncertainty principle, which states that we cannot simultaneously know both the exact position and momentum of a particle. This is not merely a limitation of our measuring instruments, it is a fundamental property of reality itself. The more precisely we determine an electron's position, the less precisely we can know its velocity, and vice versa. It is as if you were trying to photograph a person running through the dark. The more you zoom in, the less you can see of their motion. But this is only the beginning. While we have been discussing particles that behave like waves, reality becomes stranger still. Imagine directing a stream of electrons toward a screen with two slits. Classical physics predicts that the electrons should pass through one slit or the other, leaving two distinct bands on the screen. Yet in experiments with quantum particles, electrons, photons, and others, an interference pattern appears instead, as though the particles pass through both slits simultaneously. This is superposition. The particle exists in multiple states at once until it is measured. And here the paradox emerges. The moment you attempt to determine which slit the electron passed through, its behavior changes. The interference pattern disappears, and the particle behaves like an ordinary object, passing through a single slit. This is not merely a physics experiment, it is a metaphor for everything we call reality. The moment of observation forces reality to choose one possible state while all the others vanish. This leads to a deeper question: what exactly is observation? In classical physics, the observer is merely passive. In quantum mechanics, the observer becomes part of the system. You do not simply measure the particle, you alter it. It is as if reading a text changed the words on the page. And then comes another paradox: if a particle exists in superposition before measurement, what is its reality? In 1927, Werner Heisenberg and Erwin Schrödinger proposed different approaches to interpreting quantum mechanics. Schrödinger described particles as waves that spread through space, while Heisenberg emphasized that measurement collapses the wave into a specific state. Yet both approaches confronted the same philosophical question: if a particle has no definite position before measurement, then what does it mean for it to exist? And so, in 1957, Einstein, who had always been skeptical of quantum mechanics, wrote to a friend, "I cannot believe that the moon exists only when I look at it." It was not a joke. It reflected his conviction that quantum mechanics could not be a complete theory. He argued that there must be a hidden variable determining the behavior of particles, one that we simply had not yet discovered. However, experiments inspired by Bell's theorem in 1964 demonstrated that quantum mechanics cannot be explained by hidden variables alone. Reality was not merely hidden, it behaved differently. Rather than being an object we study, it became part of the very process of study itself. And so we return to the beginning: the universe is not a construction set. It is a game in which the rules change when you look. We are the players, but also the judges and the participants. Every experiment, every measurement, is not merely an observation, it is a transformation of reality itself. And if we cannot predict the future with certainty, how can we truly understand the present? Perhaps the answer is that we should stop searching for the correct answer. Instead, we should accept that reality is not an ending, but a beginning. And that every question we ask becomes part of the game. Your consciousness collapses into one reality, but the other possibilities, your alternate self staring into the abyss, your alternate self choosing to ride straight, still exist. They don't vanish. They branch. The universe doesn't pick a winner. It multiplies. Every decision, every quantum fluctuation, every flicker of a neuron's firing, it's a fork in the road. You're not just a passenger in this reality. You're a creator of it. But here's the mind-bending part: this isn't just theory. It's happening right now. Every second, your body is a battlefield of quantum possibilities. The atoms in your cells, the photons in your eyes, the electrons in your brain, all are dancing in superposition, entangled with the universe itself. When you look at a tree, you're not seeing it. You're collapsing a wave function, but the other versions of you, yourself in a parallel universe where the tree is a mirage, where the tree is a spaceship, where the tree is a thought, still exist. They're not unreal. They're unobserved. And what does that mean for free will? If every choice splits reality, are we truly making decisions, or are we merely observers of a preordained multiverse? The question haunts physicists and philosophers alike. Tegmark's bicycle ride was just a metaphor, but the math suggests something even stranger: your brain isn't a machine. It's a quantum computer, processing infinite possibilities in parallel. The neuron that fires to look right isn't just a single action. It's a split, a version of you that sees the car, a version that doesn't. One survives. The other, well, the other is you, just in a different timeline. But here's the kicker: the universe doesn't care about your survival. It doesn't care about your choices. It only cares about probability. Every moment, the wave function evolves, splitting into more branches. You're not special. You're just one thread in a tapestry of infinite threads. The math doesn't lie. It says the multiverse is real, and it's everywhere. And yet, we don't see it. Why? Because our consciousness is tuned to a single frequency. We're like radio receivers, picking up only one station. The rest is static. But what if that static is everything? What if the real world is not the one we perceive, but the sum of all possible worlds? The implications are staggering. If the many worlds interpretation is correct, then you are not alone. You are trillions of versions of yourself, each living out every possible outcome of every decision. The man who chose to look right, the man who chose to ride straight, the man who never even got on the bike, they all exist. They're you, just in different realities. And if that's true, what does it mean for who we are? Are we the sum of all our choices, or are we just one version of a greater self? The question lingers, unanswered, as the universe continues to split, to evolve, to branch, and you, the observer, remain suspended between the infinite. You, the observer, remain suspended between the infinite, and yet, you think you're making choices. But what if every decision you make is just another branch in the tree of existence? A tree so vast, so dense, that its roots dig into the fabric of time itself, and its leaves whisper the secrets of every possible outcome. You are not just a participant in this dance of probabilities, you are the observer, the splitter, the architect of a reality that fractures with every heartbeat. Consider this: when you flip a coin, the act of observation is not a passive act. It is a collision between your consciousness and the quantum realm. The coin, in its quantum state, exists as both heads and tails, a fragile, shimmering duality that defies classical logic. But when you look, the wave function splits. You see one result, while another version of you, in a parallel universe, sees the opposite. This is not metaphor. This is the mathematics of existence. The Schrödinger equation, that elegant equation, does not describe a single universe. It describes all universes at once, a multiverse where every possibility is realized, every path taken, every outcome etched into the cosmic code. And here's the mind-bending part: you are already in all of them. Every moment, every choice, every breath, your consciousness is splitting into countless versions of yourself. You are the one who sees the coin land heads. You are the one who sees it land tails. You are the one who never sees it at all, suspended in the quantum haze, waiting for the collapse, but the collapse is you. The act of observing is the act of selecting a reality. You are not just a witness. You are the creator of the narrative. But wait, what if the collapse never happens? What if the wave function never collapses, and instead, it splits endlessly, creating an infinite cascade of universes? This is the radical idea that shook the foundations of physics. If the wave function is deterministic, as the Schrödinger equation suggests, then the illusion of randomness is just that, an illusion. The coin does not fall randomly, it falls every way at once. The only randomness is in your perception. You are not seeing the coins fall. You are seeing yourself in the fall. Imagine a machine that clones you in your sleep. One copy is placed in a room labeled 0, another in a room labeled 1. When you wake, you don't know which room you're in. To you, the number is random. But in reality, the machine has simply split you into two. The same applies to quantum mechanics. The coin's collapse is not a choice made by the universe, it's a choice made by you. Every time you observe, you are filtering the infinite possibilities into a single, subjective reality. This is why the many worlds interpretation is so unsettling. It suggests that your life is not a single story, but a library of infinite stories, each one equally real, equally valid, equally you. You are not a single person. You are a multiverse of selves, each one living out a different version of your choices. The pain you feel in one universe is the joy of another. The love you experience in one is the loneliness of another. And yet, you think you're the only one who exists. But what if the universe is not a place, but a process? A continuous splitting, a continuous branching, a continuous creation of realities. Every moment, every decision, every breath, your consciousness is splitting into new branches. You are not just alive. You are multiplying. You are the observer, the splitter, the architect of a reality that defies the limits of time and space. And here's the final, terrifying thought: if you are already in all these universes, then you are the one who sees the coin land heads. You are the one who sees it land tails. You are the one who never sees it at all. You are the observer, the splitter, the architect of a reality that fractures with every heartbeat, and you, the observer, remain suspended between the infinite. The universe itself is a vault of secrets, and every interaction is a leak. Imagine a single photon, a whisper of light, colliding with the surface of a quantum object, say, a subatomic particle suspended in a vacuum. That photon, that infinitesimal messenger, carries the truth where the particle is. The moment it reflects, the secret is no longer hidden. The particle's superposition collapses, and the universe snaps back into a single, coherent reality. This is not a choice made by the particle, nor by the observer, but by the very act of knowing. The cosmos is a mirror, and every reflection shatters the glass. This is where the many worlds interpretation whispers its heresy. Hugh Everett's theory, dismissed as madness in our universe, suggests that every possibility branches into a parallel reality. The particle isn't in two places at once, it's in every place, but each version of it exists in a separate universe. The wave function never collapses, it splits. You, the observer, are not a participant in this dance, but a thread in a tapestry of infinite threads. And yet, the universe we experience is just one thread, one version of the story. But why can't we see this? Why do macroscopic objects, tables, cats, even the air we breathe, never defy the laws of classical physics? Because the universe is a detective, and every interaction is a clue. A cat, for instance, is a system in constant contact with its environment. The moment it interacts with a photon, a molecule, a grain of dust, the quantum secrets of its existence are exposed. The wave function collapses, and the cat is either alive or dead. The universe does not tolerate ambiguity in the macroscopic world. It demands certainty. And yet, in the quantum realm, uncertainty is the rule. An electron in an atom orbits the nucleus not as a particle, but as a probability cloud, a shimmering haze of possibility. It exists in all positions at once, until it is forced to choose. this is not a flaw in nature, but a feature. The quantum world is a realm of potential, where the act of observation is not a violation of reality, but a definition of it. The universe is not a machine, but a poem, and every word is a question waiting to be answered. The quantum world does not vanish when we look at it. It reveals itself. And in its revelation, we find not just the secrets of matter, but the secrets of our own existence. The universe is not a puzzle to be solved, but a story to be lived. And the next chapter? It is written in the silence between the particles, in the spaces where the wave function still dreams. The silence between the particles, in the spaces where the wave function still dreams. Here, in the quantum void, the universe whispers secrets that defy our senses. Imagine a world where every choice, every flicker of thought, splits reality into infinite threads, each thread a universe, each thread a version of you. This is the many worlds interpretation, a radical idea that challenges the very fabric of existence. But how do we test it? How do we prove that the cosmos is not just a stage, but a labyrinth of possibilities? Enter Max Tegmark, the mathematician who dared to quantify the impossible. His calculations pierced the veil of the neuron, a biological machine that hums with the chaos of life. If the brain were a quantum computer, it would need to harness the fragile dance of superposition. Yet, the human body, a warm, wet, bustling hive of activity, offers no sanctuary for such delicate magic. Decoherence, the enemy of quantum coherence, would unravel any attempt at superposition in milliseconds. A single water molecule, a single sodium ion, could collapse the wave function, erasing the ghost of possibility. But Tegmark didn't stop at theory. He conjured a thought experiment as daring as it was absurd: quantum suicide. Picture a machine, a quantum gun, primed to fire or click based on the collapse of a particle state. Place your head in its path. If the universe is a single thread, you'd hear a single gunshot. If it's a tapestry of threads, you'd hear only clicks, each one a universe where you survive. The math is brutal. Surviving a minute would require surviving 1 quintillion chances. A probability so infinitesimal, it defies comprehension. Yet, if parallel universes are real, you'd live forever, a ghost in the machine, clicking through eternity. But is this a test of reality, or a mirror to our fears? The many worlds interpretation is a philosophical minefield. Does it mean we are all fragments of a cosmic kaleidoscope, or is it a convenient fiction to explain the incomprehensible? The Copenhagen interpretation, with its collapse of the wave function, offers a simpler answer, but at the cost of abandoning the idea of objective reality. And what of the quantum computer itself? The machines we build today are fragile, cold, and isolated from the world. They exist in laboratories where temperatures approach absolute zero, where even the faintest whisper of heat can destroy their fragile dance. Yet, the human brain, warm, chaotic, alive, remains a mystery. Could it, in some unknowable way, be a quantum machine? Or is the mind a classical illusion, a shadow cast by the universe's quantum underbelly? The experiment, if ever conducted, would not just test physics, it would test the limits of consciousness. If you survive the clicks, you'd know the universe is a tapestry. If you don't, you'd be forced to confront the haunting possibility that reality is a single, fragile thread. But in the silence between particles, where the wave function dreams, the question lingers: are we observers of the universe, or are we part of its infinite, quantum symphony? The endless, unyielding decay of a body that never truly dies. Lewis's lecture, published posthumously, became a haunting parable of quantum consciousness. He argued that if the many worlds interpretation holds, every moment of existence is a branching tree of possibilities. Each decision, each heartbeat, each breath splits reality into infinite threads. But what happens when those threads collide with the inevitability of death? The paradox is not in the physics, but in the mind's refusal to accept its own fragility. Imagine, if you will, a world where your consciousness is not bound to a single timeline. In one branch, you age gracefully, sipping tea in a sunlit garden. In another, you are a child again, laughing with friends who never grew old. In yet another, you are a shadow of yourself, trapped in a body that withers but never dies. The many worlds interpretation does not promise immortality, it promises a multiplicity of existences, each one a version of you, each one a story you cannot share. But here lies the cruel irony: the observer, the one who wakes up to the world, is always the one who survives. The dead cannot question the nature of their demise. The living, however, are trapped in a loop of infinite possibilities, forever choosing which branch of reality to cling to. This is the quantum suicide experiment's true horror, not the death itself, but the knowledge that you are always the one who lives. You are the one who remembers. You are the one who wants to live. And yet, the universe does not care. It does not grant wishes. It does not bend to the will of the observer. It merely is a vast, indifferent tapestry of probabilities, where every choice is a thread, every death a silence. The many worlds interpretation does not offer salvation. It offers a mirror, reflecting back the terrifying truth: you are both the creator and the prisoner of your own reality. So, what does this mean for us? For the billions of lives that flicker and fade, caught in the dance of quantum uncertainty? Are we mere spectators to a cosmic game, or are we the architects of our own fates? The answer, perhaps, lies not in the equations or the experiments, but in the quiet, unspoken question that haunts every living soul. What if we are not just observers, but participants in a reality that is, at its core, a story we are still writing? And if that is true, then the greatest paradox of all is this: the universe may be infinite, but our understanding of it is bound by the limits of our own consciousness. We are both the observers and the observed, the creators and the created, the questioners and the answers. And in the end, the only certainty is that we are here, alive, aware, and forever entangled in the quantum symphony of existence. And yet, here we are, alive, aware, and forever entangled in the quantum symphony of existence. The universe, in its infinite complexity, whispers secrets that defy our grasp, yet beckon us to listen. Consider this: the very fabric of reality is not a single thread, but a tapestry woven from countless possibilities. Every decision, every breath, every flicker of consciousness splits the cosmos into branching paths, each a universe of its own. Take the Cuban Missile Crisis of 1962. A moment frozen in history, where the world teetered on the brink of annihilation. Yet, in the annals of time, a single act, Vasily Arkhipov's refusal to launch that nuclear torpedo, became the fulcrum of a multiverse. In one reality, the Cold War escalated into nuclear winter; in another, the world averted catastrophe. We, as observers, exist in the branch where peace prevailed. But what of the others? Are they mere echoes, or do they pulse with their own versions of us? The many worlds interpretation, once a fringe theory, now looms as the most unsettling mirror to our existence. It suggests that every quantum event, every photon's path, every particle's spin, splits reality into infinite parallel worlds. You, me, every thought we've ever had, exists in some version of the multiverse. In one, you're a president, shaping history with a pen; in another, you're a child, chasing fireflies in a forgotten village. The implications are staggering. Are we mere fragments of a greater whole, or do we each hold the cosmos in our hands? But here's the paradox: if all possibilities exist, then what defines us? The physicist Max Tegmark once asked, if the universe is a multiverse, what does that mean for our identity? The answer lies in probability. In the quantum realm, some branches are more likely than others. Your existence in this reality is not a certainty, but a statistical anomaly, a flicker in the cosmic dark. Yet, here we are, conscious, questioning, alive. And what of the critics? They argue that the many worlds theory is a philosophical nightmare, a universe too vast to comprehend. But even they cannot deny the evidence: quantum entanglement defies locality, and the wave function's collapse is an illusion. The universe does not choose, it branches. Every moment, every choice, every heartbeat is a fork in the road. Imagine, then, a world where your past selves, those who made different choices, lived different lives, still exist. In one, you're a Nobel laureate, debating quantum immortality with your younger self. In another, you're a stranger, lost in the streets of a city you'll never visit. The multiverse is not a place, but a state of being. It is the infinite library of all possible stories, and we are but one chapter, one thread, one fleeting echo of a cosmos that refuses to be contained. And yet, we cling to the idea of a single, linear reality. We build our lives on the illusion of choice, of agency. But what if our choices are merely the surface of a deeper, quantum truth? What if the universe is not a stage, but a kaleidoscope, and we are the fragments, forever shifting, forever connected? The question is no longer whether the multiverse exists. It is whether we are ready to live within it. To embrace the chaos, the beauty, the terror of infinite possibilities. For in the end, the quantum universe does not ask us to choose. It asks us to exist, and in that existence, to find meaning in the endless, shimmering dance of possibility. And in that existence, to find meaning in the endless, shimmering dance of possibility. But what if the universe itself is not a stage for our stories, but a script written in probabilities, where every choice, every observation, is a thread in the fabric of reality? The double-slit experiment, that haunting paradox of quantum mechanics, reveals a truth so alien it defies our senses: particles do not choose to be particles or waves. They are both, until the moment we look. The act of observation collapses the infinite possibilities into a single, tangible outcome, a cosmic game of quantum Russian roulette. This is not mere theory. It is the bedrock of modern physics, the foundation upon which our understanding of matter, energy, and even time is built. Yet, the implications stretch far beyond laboratories. If reality is a tapestry of probabilities, then we are not the architects of our lives, but participants in a grand, unfathomable script. The particles in our bodies, the stars in the sky, the thoughts in our minds, all are entangled in this quantum web, dancing to a rhythm we cannot fully grasp. But here lies the paradox: the more we try to unravel the mysteries of the quantum world, the more it eludes us. Science, for all its precision, cannot answer the question that haunts every seeker: what is the nature of existence if reality is, at its core, a probabilistic illusion? The answer may lie not in equations, but in the silence between the notes of the universe, a silence that whispers, "You are here. You are now. And you are part of something far greater than yourself." So, what do you think? Is the universe a stage, or a mirror? Like, subscribe, hit that bell, and let's keep unraveling the threads of existence together. Because in the end, the greatest mystery may not be the quantum world, but us.